Hi, everybody, and welcome to today's webinar on designing Wi-Fi in higher education. My name is Kelly. I work here at iBwave, and I am joined by our special guest and today's presenter, Rowell Dionicio, CWNE number 210, and host of the popular Wi-Fi podcast, Clear to Send. Before we get started, I'm just going to quickly go over a couple of housekeeping items. Firstly, we are going to be recording the webinar, and we will send out a copy to everyone shortly after the webinar is completed. Secondly, we are going to take questions as we go through the webinar. So if you have them, please use the GoToWebinar chat box on your screen and send them to us, and then we'll get to the ones we can and try to follow up with the ones we can't after the webinar. So with that being said, I think we're ready to roll. So Rowell, I'm going to hand it over to you.
All right. Thank you. Thank you for having me, iBwave, and thank you everyone for joining us here on this webinar about designing Wi-Fi networks in higher education. And so the agenda that we're going to go over today, I'm going to talk about some of the challenges that we are seeing today, the approach that I take and many other people take to Wi-Fi design, designing for capacity in large spaces, and also talk about the upcoming Wi-Fi 6 and the considerations you should take and looking into the future. So hello again, my name is Rowell Dionicio. I'm actually a network engineer in higher education. I also do a lot of Wi-Fi design and configuration for enterprises and other institutions. And I also co-host the Clear to Send podcast at cleartosend.net, where we primarily talk about Wi-Fi. So if you want to learn more, you can head over to the podcast and engage with me there. So some of the challenges that we run into today, a lot of this is because everything is going wireless or everything is already wireless, but we still have these challenges in deploying wireless, right? Because we have things like aesthetics that we have to follow, and we don't want to, or people don't want us ruining the aesthetics of the environment. It used to be coverage based previously, but now we have to design for capacity. And then we have BYOD, right? Everybody bringing in their own devices onto the campus, and we don't really know what devices those are and what their capabilities are. And then with Wi-Fi being invisible, there's a lot of troubleshooting sometimes that has to happen. And so we have to know how Wi-Fi works in order to troubleshoot it efficiently and come to a root cause much faster. And then we have all these innovations that are coming in the future that utilize Wi-Fi networks, and we'll talk about that in the upcoming slides. And I'm sure a lot of you guys also have way more challenges than what I run into or what I've experienced. And what we could do is maybe some of you guys can put that into the chat and talk about what kind of challenges you're running into. Maybe there's something that I haven't covered, and we could also let everyone know what you're seeing on your campus to help prepare them for the future. So like we said in the beginning, if you have any questions, go ahead and put that into the chat, and Kelly will interrupt me if there's a question I should answer during any of these slides. So I'll try to go fairly quickly here because we have about an hour, and I do want to leave some room for questions. Now, I don't have all the answers, but I'll try to answer everything the best that I can. So moving forward, Wi-Fi design. Why must we design Wi-Fi? Why can't we just place access points up wherever we want? I always reference this quote, which is, give me 6 hours to chop down a tree and I will spend the first 4 sharpening the axe, because I like to plan as much as I can up front. So after the fact, when Wi-Fi is deployed, I don't like having to fix it because I didn't plan for what was going to happen in that environment. There's somebody that I work with that has about 30,000 plus clients in their campus. On the campus I work at, we also get over 30,000 clients. And that's a big number, right? That's a large number of wireless clients on a network in a fairly large campus. And so we can't just leave this up to just guessing where access points should be and how infrastructure should be. We should treat it as we do with the wired network, as we have always done, is we plan for these things, we design it, we architect it. But then a lot of people still ask, well, why do we still have to do that if we place an access point? Wireless signal just propagates everywhere, right? That's still somewhat true, but we have a lot more services that rely more on Wi-Fi. We need something more reliable. We need something a little bit more predictable when it comes to Wi-Fi. And those things could be modernizing the campus experience, right? So there's a lot of different departments within a campus that want to integrate wireless technology with campus life. So that could be residential and dining. They have some maybe applications with ordering food, for example, and then you can just pick it up, and you'll need to use Wi-Fi if you're on the property and you want to order your food for the cafe from the cafe. There's meeting spaces that are heavily using wireless technology, not just within the meeting space, but even when it comes to finding a meeting room. A lot of different campuses are trying to use location-based services to determine which meeting space is empty. Transportation starting to utilize Wi-Fi. There's like Wi-Fi being deployed in parking lots, for example. And then we have the classroom environments where it used to be where your students would just sit and listen, but now I'm starting to see professors interacting with those students and telling them to perform an action, which requires them to use their laptops or mobile devices to do something on the internet. And then there's other things where services are more streamlined. So let's say you're getting in line somewhere, you can do some sort of auto check-in, for example, because your mobile device came within to the area and it was detected that you're in a specific room and it could check you in. And that's just one of those examples. And we're just in that phase where that instant gratification is needed because we don't want to wait. We want things to be more efficient. And then there's also the smart campus. I've had requests to put, excuse me, Wi-Fi in restrooms. It's kind of a weird request, but when I heard the use case, they were trying to be more efficient with handling staff to replenish supplies in restrooms. So they wanted some sort of sensor in a paper towel dispenser. And so when it got to a certain threshold, say maybe 20% of it is left, they could go in there and refill it rather than having to visit every single restroom. There's people wanting to see sprinkler systems on Wi-Fi. There's AC and lighting, trying to make that more efficient, and trying to figure out how often people are occupying spaces. There's people using Wi-Fi for that, and also a lot of thoughts around using Wi-Fi for building access. So if you put your badge on your mobile device that we always carry, maybe you can just, when you get near the door, it would just open it for you. And then lastly, I always like to talk about capacity because on a campus, there are lots of high density areas that require the capacity planning. And the difference there being we have the high density areas, but maybe it's the type of applications that's being used in that environment. So when it comes to the life cycle of how we design for Wi-Fi, there's the slide that talks about collecting requirements, identifying constraints, doing your design, deployment, and validation. So I'll talk about each of these, and I might go kind of quick. So if you guys have questions, I'll try to answer those at the end or during the slide. So before we actually deploy wireless, we want to collect requirements because by failing to prepare, you are preparing to fail. And I've gone through this before where somebody wanted Wi-Fi and maybe I was just time constraint. So I deployed it, but then it didn't meet their requirements. And that's because I didn't figure out what those requirements were. So what exactly do you collect? Now, this is not the end all of collecting requirements. This is just some of the requirements like the location. I like to physically walk the location and see what it looks like. I have a floor plan. I look to see if there are any walls missing from the floor plan, or maybe there's added walls or added rooms from the floor plan. I've run into those scenarios. What type of building materials are used, because that's going to affect the attenuation of the signal and how far that signal can go. For example, you might see a wall where it looks like drywall, but behind the drywall could be brick or cement or metal. I've seen different scenarios like that. We also want to know where are the network closets, right? Because you want to know if you could run Ethernet to where you need the access point, and maybe that exceeds the length. So that's important to know things like that. And like I said earlier about floor plans, I always grab the floor plans as much as possible because that's what I'm going to use for my design. So in addition to that, I like to collect what the intent is, right? How are they going to use Wi-Fi? What type of applications will be used? Now, when I ask these types of questions, usually most people don't know what the answer is, right? It could be for a lecture hall, and I could ask a question like, so how do you plan to use Wi-Fi? And they're just going to say, well, students are going to walk in, and they might not know what applications the students are in, because I don't know if you've sat in a class and watched how students use Wi-Fi. A lot of them aren't even paying attention to the professor. They're either watching last night's football game, the highlights, or they're looking at YouTube and just looking at things that aren't related to the class. But the professor will tell me what application they might be having the students use, and that kind of gives me a hint for designing around that, but also keeping in mind that other applications might be used. And then you have your BYOD, because I can't simply ask the professor what type of devices are going to be there, right? And that's why sometimes I sit in and look to see what kind of devices are currently being used, or if you have an NMS or a network management system that tells you what are the most common device types, that helps as well. So typically I will design around Apple devices. I live in California on the West Coast, so a lot of the people here tend to gravitate towards Apple devices. So that's kind of what I design for. That's primarily the operating system that's being used. And then I want to understand what those device capabilities are, because if you've got a MacBook Pro from 2010, compare that to today's MacBook Pro, different wireless specs altogether. Or if somebody's using an old iPhone compared to a newer iPhone, those have different Wi-Fi capabilities as well. So that's how I'm going to try to determine on, okay, maybe I should design for the worst client in the environment, because maybe that's what they could be using. Or even on a classroom space where they have those laptops and carts and they're using Chromebooks, for example. So that could be one of the requirements I collect, saying, okay, you're going to hand out these Chromebooks during your class, and that's what you're saying is your most critical device and the application that's being used, whether that's just a web browser or what are they downloading on the web. I ask as many questions as I can, and I actually have them show me what they're going to do over Wi-Fi, so I can try to plan for that application, the capacity, and the density. And then I collect information from, say, the building manager to determine, okay, where do you have any requirements for me as far as I can't put access points here, or maybe I can put them there. Um, I've had building managers say, excuse me, I've had building managers say they don't want to see the access points. And so I tell them how Wi-Fi works, because you shouldn't hide the access points, because if you hide them in the walls, then the signal has to go through the wall. And what I typically do is I bring two different scenarios with me. I bring the ugliest co-location mount with me, right? It mounts to the wall, it mounts the AP, and it also mounts an antenna. It's a large enclosure type that's co-location mount. And then I also bring maybe an external antenna or just the access point itself. And I won't even give them multiple options. I just say I can do it like this, which mounts on the ceiling with the co-location mount, or we can just mount the AP. And usually I just have them gravitate towards the solution I really wanted them to use, and that kind of works in my scenario. So you want to consider some of those aesthetics, and maybe you do have to use external antennas to help kind of blend in with the aesthetics. All right, so next you wanted to identify the constraints, but don't let them stop you from trying to deliver Wi-Fi service that everybody needs, right? So some of those things could be regulatory. I don't know if anyone here is from a different country, but you want to know what frequencies you could use and the transmit power regulations, and using the right country code with your controller, for example. And again, the aesthetics, I don't want to beat that up too much, but I typically get, oh, wow, that access point is huge and it's ugly, and then architects say, no, that's going to ruin my beautiful building. I don't want that to be installed anywhere. So we usually have to juggle with that, right? And then you have those budgetary constraints. I don't know how some of the other campuses allocate budget for wireless and infrastructure and cabling, but that's something to consider based on how many access points you're going to install, right? So however many access points you're going to install is also going to determine your POE requirements. So there's also the POE budget, and then that's going to determine how many switches you're going to need and the cabling. So usually that's the most expensive part, is the cabling, and then you want to minimize how much you're going to go back and try to fix that post install. And so that's what we want to try to minimize with a lot of planning and designing. And then you want to pick your vendor. So if you're going through an upgrade cycle, determine the cost per access point, how much is licensing, are you going to use a controller or multiple controllers versus cloud managed, and then also the cost of antennas if you need them. And I'm a huge proponent of using antennas because it can shape the RF signal, but if that's not possible to do, that's going to be a constraint for me. So I'm going to have to work with using maybe omnidirectional and built in front in the access point. And then there's building codes, which, to be honest, I'm not too familiar with building codes, but I try to work with the building manager and the installer to make sure, one, that the safety is important, because I don't know about you guys, if you deal with faculty members, sometimes they get pretty agitated if somebody is working in their office and a speck of dust might fall off the ceiling, and we got to consider things like that, and installing APs not too close to sprinkler heads. So that's where a walkthrough comes in handy, and then you want to get that buy-in, right? So trying to accommodate a lot of people's constraints, or make it sound like you can accommodate them. So it gets the buy-in there. And so I try to work with everyone that's involved. So here's a classroom that had a couple of constraints for me. This seats about 186 people, I believe. They renovated this classroom, and this used to have just one access point to service this whole room. And so that was good back in the day when nobody was using wireless. And so when redesigning this room, one access point could technically, fill this, the signal could fill this room. If you looked at a heat map, green, people always say green is good, but green is good for coverage, right? So when we talk about capacity, what type of applications being used, and then the constraints, my constraints were they didn't want the access points to be seen at all. I couldn't mount them to the wall. I couldn't even mount them to the T-bar on the ceiling. And so I have to deal with that. And we'll go back to this image in the future slide, because I'm going to tie this in with antennas and design. And so maybe you might have also a lecture room that is elevated. And I do have one of those, which I'll show you in a future slide. But you want to accommodate that as well, because there's going to be at different heights. And so where do you place your access points or your antennas? How do you account for bodies in the room, right? And the attenuation of bodies, because we're made mostly of water. So there's going to be some signal loss there. And so within iBwave, you can actually account for this and plan that in your auditoriums if you have huge auditoriums or lecture halls. So once you collect all those requirements and you identify the constraints, now we start with the design. And so I kind of want to pause here and see if anyone has any questions, or does this sound familiar? Am I repeating something that everyone already knows?
I
Kelly.
don't have any questions so far, Rowell, so maybe we can take that to mean everyone agrees.
All right. So we'll
I'll
start
let
with
you know.
okay. So we'll start with the design, right? You collected all your requirements. Now you need to open up your some application to create a design. And so there's different tools and applications to help in this design process to help you get to that end result. And so some of the considerations here in your design is your access point and antenna selection, which one you're going to use, because they're all different. They all have different propagation patterns, and that's that's very important to understand, which I'll go into later. You want to know if you're going to do static versus RRM or something other than not just RRM, but any other vendor's automatic algorithm to determine channels and transmit power. You want to keep that in mind. And also, most importantly, is keeping in mind the device types, because a lot of us like to focus so much on the infrastructure side, the access points, but what about the devices? Because not all devices are the same. They all have different types of radios. They're vendor manufacturer proprietary, so they all have their own algorithms, and they all have very different capabilities. And so you want to keep design with the device types in mind. And then you're going to use your design application, something that's focused on just creating a design for your wireless environment. And obviously you're here watching this webinar, so iBwave Wi-Fi is going to be a good example, which they have something on desktop and on a tablet, and you could use this for validation as well after you've deployed it, which I'll go into. So as we're designing for capacity, I think the most common question, the most asked question by people is how many access points do I need and how many users can I put on an access point? And so what I like to say there is when you're trying to develop that number, how many access points, the design application can help you determine what that number is, because you're going to put in all those requirements, you're going to put in your floor plan, you're going to put in your coverage areas and what type of applications are going to be used in that environment. And because we have computers now, right, a lot of this math can be determined for you. And I'll show you how I could do it the manual way, which I don't do this anymore. I use the design application to determine this for me, and then I adjust how I see based on the environment. But that's I trust the application to help me determine how many access points, and I don't like to put a lot of users on access points, right? So you'll see vendor documentation that says we can put 1,000 users on this access point. I mean, that might be true. You could probably associate 1,000 clients on an access point, but what happens if they all 1,000 users start watching an HD video? I'm pretty sure that might not be a good experience for everyone. So that it really depends on what type of application is going to be used on Wi-Fi. And then also antennas, depending on what antenna you use, those have different propagation patterns. So we want to use an antenna to shape the RF signal to where you want it to be, and you're going to create things what's called contention domains. And a contention domain is because Wi-Fi is such a finite resource. There's so many channels that we could use for Wi-Fi that we don't want to have Wi-Fi like access points contending for airtime on the same channel. We want to plan that accordingly, and again, the application, the design application, can help you do that. And then we also, I don't know about you, on my campus, I still do some temporary installs for events. So sometimes we have to put up a temporary solution using a tripod and mounting the access points on those tripods, which I have some photos I can share with you with how I deliver Wi-Fi kind of quickly and to meet demands of an event that might not be like the normal classroom. And then also designing for interactive learning or instruction, which I mentioned earlier. I've worked with a professor to understand, okay, you're telling me you have this interactive teaching that you're doing. What exactly are you telling the students to do, and what do they have to do over Wi-Fi? Because I had this professor tell me he was in one of the auditoriums, lecture halls on campus, and they had a very poor Wi-Fi experience. Even if it was just him telling students to go to a web page, with all 100+ students trying to do that, it was kind of slow for a lot of students, so hit or miss for a lot of students. And he was in an older a room that was designed a long time ago and just had one access point in the very back, and it just wasn't able to keep up with that capacity. And so I moved him to another room, which I'll show some pictures, and that actually helped by me creating these different contention domains. We were able to put a certain amount of users on access points, so that way that load is kind of distributed across different access points.
Rowell,
Yeah,
can I interrupt you with a couple of questions here that we've gotten?
sure.
So one is, in terms of capacity planning, what SLA do you try to achieve?
So I don't really try to achieve an SLA. I try to provide the best signal and quality of that signal to the user. So if they can get more than, because everyone does speed tests on campus, I kind of like it but don't like it. But everyone's just testing the wireless network. So if I can get people to do a quick test and they can get over 50 megs up and down, right? Just to quickly test it, because typically user traffic is small burstable traffic. And so that traffic is gonna, I just want to get users on the wireless medium and then off as quickly as I can. So I'm not really trying to meet an SLA. I've never had someone say I absolutely need at least 2 megs per person, um, because wireless is a shared medium. It's unlicensed frequency. If somebody had a cordless phone that operated on 2.4 gigahertz and we were using that same frequency as well, that kind of kills the SLA, right? And I can't do anything because it's unlicensed frequency. I can say, hey, can you just turn off that phone? But I mean, if they're using that phone or maybe an analog video, um, that's just kind of puts that SLA out the window. And so I'll kind of go through a little bit of that with this slide. Um, are there any other questions before I go into this, Kelly?
I do. It's not so much capacity though, but the question is from Anders actually. In terms of auditoriums, do you recommend overhead or under seat mounting, or what would be the pros and cons of each?
Yeah, so I've always done overhead mounting because it's been easiest in terms of budget and installation. My installers have access to above the ceiling, and we install that way. I have looked at under seat deployments, but the cost has always been too high, and we just never went that route. So the answer is I've never done an under seat deployment, so I can't give you a pros and cons.
Okay. And I have one question that just popped up, I think relevant to the slide you're about to talk about. What is the meaning of the 2x2 two?
Sure. Okay, so I'll hop into the slide then, if that's okay.
Yeah, makes sense.
All right, so here is a spectrum analyzer, that image there at the top. And what I'm measuring is somebody doing a test with a bunch of Chromebooks that was 2x2, 2, right? So that's 2 transmit, 2 receive chains, 2 spatial streams. These are Chromebooks. And I had an access point operating on channel 40. And so that's what that graph looked like with those 8 laptops. It was they were they were doing a test with just 8 laptops, but there was going to be about like 36 laptops, I think, in use altogether in 3 different rooms. And part of that Chromebook experiment was each student had to take an examination on the Chromebook, and they would have to download audio files as part of the test. Um, So what I did is capture the spectrum on it, just because I wanted to show what that looked like with 8 laptops there. And so that's what that 2x2 2 is: 2 transmit, 2 receive chains, and also 2 spatial streams. And that's important because when I try to do this math manually, right, like let's say the application throughput is 2 megs, 2 megabit per second, and my devices are these Chromebooks, 2x2, 2 spatial streams. If you look at the MCS index, they'll get about 144.4 megabits per second. That's like the raw. But in actuality, it's probably half that. So it's 72.2 megabits per second because Wi-Fi is half duplex. And so that means to determine the airtime for that application, you take the 2 megabits per second, divide that by 72.2, and then multiply it by 100 to get the percentage. And that's it's gonna that application is gonna take about 2.77% of the airtime. And so I did it based on, okay, what if there's 160 devices? You multiply that by 2.77%, and then there's a the vision of 80 there because, well, we won't really ever see like 100% utilization on a radio. So I like to base it off of 80% there because at 80%, you're going to really start to see some performance hits. And so when you do that, it's telling me, the math is telling me I need 6.3 radios, and you round that up because you can never have, you know, 0.3 radios. So that's technically four APs. And so when I did that math, I mean, this is not even that accurate, right? There's going to be other devices in the area. They're probably going to be using other applications because this was a room that was adjacent to other rooms and also adjacent to a hallway where a lot of students like to hang out. And so my guess was some of those students will probably associate to this access point as well. And so the point that I'm trying to say here is I don't do this math anymore. I either use the design application such as iBwave to help me determine how many APs I'm going to need based on these requirements, or you can use this really handy tool by Andrew Van Aj at Revolution Wi-Fi. He created this capacity planner in Excel, and it's very detailed. And so here, this is screenshots from his capacity planner, and it's in Excel. And so here I am putting the AP. A lot of these are defaults that I picked here, right? So there's 3 SSIDs. What are my basic data rates? And here I'm putting a laptop that's a 11N laptop, 2 spatial streams, and then you can put your application or throughput SLA, and then how many devices. Earlier I said 160, but I put 186 in this example. And then when you calculate it, it says 4 in the red box there, 4 dual radio APs with two radios disabled and 2.4 gigahertz. So you can kind of do this as a little bit more accurate. Andrew's math is pretty intense when it comes to this, and you can kind of see the different cells and sheets that he's got there. But again, my point is I don't do the math in my head. I don't write it on a piece of paper. I use other tools to help me determine how many APs I need based on the requirements.
And Rowell, if I can just jump in with a couple questions around capacity. Do you have to worry about the DHCP and IP addresses for the client devices when it comes to capacity?
Yes. So on my campus, there's another team that handles the DHCP servers, but we've allocated, I use like /22s, really large networks on campus. So there's been times where we do exceed, we've depleted all the available addresses, yeah. And we have monitoring in place that at least helps us to determine, okay, it is a DHCP issue.
Okay.
I hope that answers.
Yeah, and this next question, what kind of minimum throughput do you typically see that allows the best kind of user experience on modern apps such as social media, YouTube, Instagram, etc.?
Yeah, so those are bursty applications, a lot of download if they're just browsing. At events, I see a lot of upload because people are taking pictures and then, or video, and then putting that, uploading that as well. I don't, at some of the events that I've seen, I have not exceeded 1 gig on a port, on an AP's, on a switch port to an AP. With that said, I probably see less than like 50 megs usually, because again, that traffic is usually bursty and it's quick. It's never like this consistent. I'm not hitting this consistent bandwidth there on a single port.
Okay, thank you.
So again, with the capacity, here it is in iBwave where you can set the usage type. You can customize these, but it helps you determine, okay, how many access points am I going to need in this area, this, or what I call a capacity area. So before I mentioned like how important the antenna selection is, right? So if you take an AP that has a built-in omnidirectional, this is what the pattern would look like, the RF pattern. And you can see this within iBwave, which I think is really cool when you select the AP or the antenna. Even on the left side, it has your 2D 2D pattern on the horizontal and vertical. So the omnidirectional kind of looks like an apple. So that's what you consider if you mount that properly on the ceiling. right? If you mounted it on the wall, then you would just turn that actually to its side, and that's what that signal would look like. Now, if you use a patch antenna, for example, here's how the signal is not as 360 anymore. It's now in a directed path. And so if you mount this, on the ceiling, that signal is propagating down. Now, it's not to say that's the cutoff. The signal actually does propagate as far as it could go and into free space path loss. But that's something to consider when you're doing your validation survey, because also that'll affect the signal will be affected by like transmit power, for example. And so if we go back to that classroom that I had earlier, when I had the constraints where I couldn't show any of the APs, what I actually did was mount the APs above the ceiling tiles there, but I had a directional antenna that pointed down for each section, so I could try to manipulate a device into thinking it should join the more stronger signal, right, and wherever the student sits. And so that's how I try to plan for the capacity in that area. Um, and I in this scenario, like when I did the math with that Excel sheet, I didn't do 4 APs because I didn't really have another location to do a fourth AP for this small of a room. I thought 3 was going to be sufficient, and so far it has always been sufficient for the classrooms that have been held here. And then another thing to consider with your designs, right? Like if you're looking at that classroom, there's 3 APs, so you got your 2.4 and 5 gigahertz channels. Here I'm only showing the 5 gigahertz channels on the screen because I design primarily for 5 gigahertz, unless I know there's going to be 2.4 only devices. And so what I'm trying to show here is the different channel widths and how many channels are available to be reused in your environment. In the classroom environment, the previous picture, I could have just used channels 36, 40, and 44, for example, right? Now I wouldn't put them right next to each other because then you might be approaching like adjacent channel interference. But I primarily design on 20 megahertz channel widths because that gives me the most channels that I could use, especially in environments where there's a lot of APs, a high density amount of APs. I use 40 where I can, but I have never designed above 40 because in 80 megahertz, there's still not enough channels for me to reuse. And also in education, I find that a lot of devices aren't even 80 megahertz capable. So why even use 80 megahertz if they're just going to use about 20 megahertz worth of that channel? And then 160, I just completely ignore because the reuse there is not available. You can put 2 radios on 160 megahertz channel widths, and then you have to reuse the channel again. And so what I want to do is try to minimize the amount of co-channel contention, so that way I have different capacity zones. And essentially, if there's 1 or more APs servicing the same area and they're on the same channel, that's pretty much the same uh, capacity like contention domain because it's the same frequency. So going into events, and let me check my time here. All right, so going into events, here is an example of a tripod setup that I used, and you can see them with the red squares on the left and the right. So on the left, I have a tripod with 1 AP using 2 antennas. So this is the either Cisco 3802 or 2802 using the dart connector. So I can use 2 APs. The channel separation is pretty large there with those 2 APs, and those were both on 5 gigahertz. And then I have another one in the bag with 1 AP. Now, the reason why I picked those locations is because that's where I only had the jacks, and so I couldn't put them anywhere else. Not without running a cable, but I didn't want to have the safety hazard of somebody tripping over a cable and then basically tearing down the whole wireless network. I have since then did a more permanent solution. It was kind of costly because they didn't want any of the APs mounted on the wall. So you can see like it's a wood panel wall. I couldn't do it on the ceiling because my installer couldn't even get up there to run cabling. So I did it right along the top edge of the wood there. I should have added a picture, but there's just an antenna that's showing there. pointed towards the middle of the floor. So you've done your design, you're feeling pretty good about it. Now it's time to actually deploy, which means installing and configuring these access points, right? Because it's all about the execution. And so when it comes to configuring, you want to understand what these knobs do, right? A lot of people, I think, don't completely understand how RRM works. That includes like every single vendor's. I just use RRM to encompass all the vendors, even though that kind of applies to Cisco, but understand how that algorithm works so you can understand how it's trying to pick those channels for you and transmit power. When it comes to load balancing, I do not use that feature. I've been burned by that feature a couple of times, and I just don't think uh, the infrastructure should be telling the client where to join, because ultimately the clients decide which access point they want to join. I mentioned this before, channel bonding, use 40 megahertz if you can. If not, because maybe you don't have enough channel reuse, then drop down to 20 megahertz. Because as you increase the channel, um, you need better SNR or signal to noise ratio. And the signal to noise ratio is a good metric because that's the quality indicator of that signal. And then a lot of people talk about data rates. Should I keep low data rates on? Should I raise them as my minimum data rate? I say don't go crazy without testing, because when it comes to a BYOD environment, you just never know if a client needs to use lower data rates. And maybe because it needs to use a lower data rate because maybe it needs to send a signal or transmit its signal at a lower modulation, right? So it has to use a lower data rate, because sometimes the lower data rates are better for the stability for the client. So here's an example of a data rate example. I took this the other day. This was my iPhone 10, and my lab wireless network, I set it to a minimum of 24 megabits per second. This is on the 5 gigahertz. That was my minimum data rate, 24. Now, this is just a section of time where it was transmitting and receiving data. So you can see that that flat line in the beginning, that's 24 megabits per, the data rate of 24 megabits there. And then it sometimes jumps up, right? It transmits at a higher data rate. But what's more interesting is those two red squares that I highlight there. That is my phone trying to transmit at a 6 megabit per second data rate. Now the AP is not going to acknowledge that because its minimum is 24. And so it does this for quite a bit of time, right? It doesn't look like a lot of time, but consider how quickly we transmit and receive. It's trying to do this at 6 megs. I don't know why, I didn't really analyze it, but I wanted to show you that sometimes clients will transmit at lower data rates, even though your minimum data rate is set higher. And so you want to consider that, because this here in the square, what that means is if my device is sending at 6 megabit per second data rate there, and the AP is not acknowledging it, that's a retry, because the AP didn't receive it. And so now we have this back off timer. And so the retries are what's going to make it appear like your wireless network is slow. So just be careful with the data rates and test them. So once you deploy, validate, you want to check your work, right? Here's a deployment where we said, put the APs, mount them on the ceiling tiles. Now this environment was a very, very beautiful building, and I think they just didn't want the AP to be shown. But they installed the AP with a lot of metal, and we had complaints about this specific area. And so this is what happens when you don't validate. People complain when they said, yeah, they said wireless going to be there, but this is what ends up happening. So we ended up having to move that to the T-bar there. Here's another one where someone just didn't install it all the way, right? They made all the effort to put it on this mount, but they needed to flip it upside down and attach it to the T-bar there. Here's another one where I don't have no idea where the 3 other antennas went. I believe this one was installed at a gym, and I think by the time we got to the validation, somebody had broken the antennas off, I think. So we had to replace the AP and put it in an enclosure. So here's how an antenna should be installed. This one's a down tilt Omni antenna for Meraki. That one's nice and clean. It's mounted on the ceiling and it's pointed downwards. Here's that lecture hall that has that incline there. And so I couldn't mount anything on the walls, so I went with the ceilings. Now some of these are a little too high for my comfort, but sometimes it's better to have signal than no signal. So the APs are mounted up in the above the ceiling, and I have these antennas, patch antennas pointed towards the seats. And this was a large room. So this room used to have, I think, only 1 or 2 APs omnidirectional in the back and in the front. And now it's got, I think, 1, 2, 3, 4 APs. And I'm using dark connectors on 2802s. All right, so that's the deploy. I know Wi-Fi 6 is around the corner, so we want to talk about some of the considerations for Wi-Fi 6, and then we can answer any other questions.
Can I jump in, Rowell? One question about the data rates.
Yeah, go ahead.
Have you found situations where you need to limit the cell size of an AP by increasing the minimum data rate?
I do when I have more APs in a given area, but I still don't go, in most of my environments, I don't go above 12. And that's because I have to support a BYOD environment, and some clients are just not as capable as other clients, and I still prefer the lower data rate for more reliability and stability of that signal getting across to the AP. Because one of the things you should consider too is it's not always about the AP to the client. The client has to communicate back to the AP. And so if it tries to send a signal at a high data rate, it modulates that signal, gets sent over the air. But let's say the AP is kind of far away, right? So RRM will do this to you. It sets the AP power level at level 1, but your client could be kind of far from the AP, but still hear that signal and say, wow, that signal is really strong. So I'm going to send this at a higher data rate. And so when it transmits that signal, the AP has to demodulate that signal, but maybe the SNR just wasn't good to receive that signal and demodulate it at that data rate. And then now you have a retry scenario where the AP didn't acknowledge receiving that frame, and your client is having to continually resend that frame. And so that's why I don't like using super high data rates for that purpose. I've seen a lot of sticky type clients where they just stick to an access point for whatever reason. And there's just a lot of clients that don't support 802.11v, for example, or even 802.11r. So we have problems like that. So that's why I like to stick with a lower data rate. I don't go above 12 as my minimum.
Thank you.
All right, so Wi-Fi 6, right? It's 802.11ax. It's not yet ratified, but the draft is really mature, and I don't expect to see that. I don't really expect IEEE to make huge changes between now and when it gets ratified. The new features with Wi-Fi 6, the biggest one I think is OFDMA, which is orthogonal frequency division multiple access. And that allows multiple access onto the multiple devices accessing the shared medium. And that's how we create this higher efficiency using Wi-Fi 6. Now, if you take 802.11ac, which is Wi-Fi 5, it uses OFDM. That is like a single transmission for a single device. It's using up the whole, let's say 20 megahertz frequency. With OFDMA, it's gonna split that frequency into smaller like subchannels. They call them resource units. And with those resource units, you could actually allot or allocate a resource unit to a different client, and that client will tune its radio to that specific frequency. And so you get better use out of that channel because now you have multiple devices communicating on that channel. And then we have BSS color, which is supposed to solve for high density, especially maybe in dorms or like apartment complexes. It's similar to RxSOP if you've played with that. I have not yet seen this in action, so I can't really comment onto how it actually works, but hopefully soon I'll be able to test it. There's TWT, which is target wake time. Because of the influx of IoT devices that are battery operated, TWT is supposed to help make the battery efficiency better for these devices so they don't continually use their battery. And it sets a schedule for when a device is going to wake up and send and receive traffic. And then there's the introduction of 1024 QAM. There's a lot of talk of whether that's possible. Do you have to be directly underneath the AP? This is how you're going to achieve your higher data rates and the higher speeds. And so Wi-Fi 6 is named high efficiency because we're really just making better use of the frequency. So because of that, this is the only device that you can technically buy right now at a store, the Samsung S10. And that's why there isn't much testing, because this is, I haven't yet seen laptops out. I know you can buy an Intel card that you can install on your laptop, and then you have Wi-Fi 6 capability, but then there's still not a lot of people rolling out Wi-Fi 6 yet. So should you upgrade? So the way I put it is, if you could wait another year or two, then I would wait. But if you're in a upgrade cycle where you have to upgrade now because you're going to either lose your funds or you, you don't do upgrades for another 7 years, for example, then I would upgrade now to whatever you can, whether that's Cisco or Aerohive or Aruba with Wi-Fi 6, because then at least when these clients start coming onto your network, you will have a Wi-Fi 6 capable network. Now, the advantages of Wi-Fi 6, I don't think we will see until we have all Wi-Fi 6 on our network, because all the previous protocols are not going to see or take advantage of these features. That's pretty much the end of my presentation. I hope you guys found some use out of it. I know there's probably a lot more questions that I can answer, but if you want to learn more about Wi-Fi, you can go to my podcast, cleartosend.net. If you want to learn more about Wi-Fi 6, go to cleartosend.net/AX, and that's all our episodes about Wi-Fi 6. And then if you want to start a conversation, you can reach me on Twitter. Those are my Twitter names there, or send me an email.
Great, thanks, Rowell. And we do have a bit of time left here and some questions. So let's just try to go through what we can, I guess.
Sure.
So one question is, how would you describe the difference in coverage between 2.4 and 5 gigahertz?
Yeah, so the signal propagation for 5 gigahertz is shorter, and it'll attenuate more than 2.4. So 2.4, because of frequency, it can penetrate better through material. So the thing is, though, that 2.4 is so heavily utilized that I don't really design for it at all. I really design for 5, but then that means I actually have more APs in my installations.
Okay, makes sense. In what kind of scenarios do you recommend to use 80 megahertz or 160 megahertz?
If you have a room that is so isolated that no other signal penetrates that room, then maybe you could use 80 or even at 160. But then you have to have a device that supports 80 and 160 megahertz. So if people are bringing in Chromebooks and they only support up to 40 megahertz, you're wasting the other 40 megahertz, and that you could maybe potentially use that for another access point. But yeah, it really just depends on your room. I know some people use 80 megahertz because they can. They do have enough isolation between any other network that they are able to use 80 megahertz, and the devices they use do support 80 megahertz or 160.
Okay. Since you use the 22 subnets, how do you manage handing them out? Are they in zones such as geographical locations? And how do you manage people roaming and holding IPs?
So we do separate them geographically as part of the campus, primarily around different schools. So like your school of medicine or your engineering school. So we reference them as quads. So sometimes quads have large networks and maybe multiple /22s. And then when it comes to roaming, we have roaming between our controllers. So as long as they're roaming, they could roam and still keep the same IP address.
Okay. So this question is, if the scope of the WLAN design install is for both indoor and outdoor, would you consider, or have you ever done it as a two-stage process? So doing the indoor Wi-Fi installed and surveyed first, and then the outdoor, let's say.
Yeah, so most of my installations are indoor with pockets of outdoor where people really need it. And so it's always been the indoor first because that's primarily where everyone really needs it. And then outdoor, we put it, I design it so that it doesn't fully penetrate into the building because then it could, what I've seen is it creates a problem for those who sit by the window and they could potentially just start associating to the access point that's outside where there could be an AP indoors with a better quality signal. So that's, I do it in that kind of phased approach. I treat it as separate projects. I never do, I, I haven't done an outdoor and indoor as one project.
Okay, thank you. This question is, if most of the clients are 1x1 or 2x2, should I consider APs that support 4x4, and how much different would performance be?
With multiple antennas on the APs, which are nowadays like 4x4, and with Wi-Fi 6, you're going to get as high as 8x8. You have at least antenna diversity. So any sending and receiving antenna, if it can get a better signal to and from that client, it's going to pick that antenna. So I think having more antennas is good on the AP side. We just don't see that on the client side because of battery consumption.
Okay. This question is about AX. So what kind of wireless card that you know of can they use to gather 802.11ax frames, either on Windows or Linux? Do you have any suggestions?
Yeah, so right now I can capture frames on my MacBook Pro. It's the later model, I think 2018, not 2019. But I have to do it in an active mode. So I use this tool called Air Tool on the Mac, and you can capture the frames that way and then use Wireshark, or you could use Wi-Fi Explorer on the Mac as well. Um, I you could probably do it also on Windows using OmniPeak with the adapters, as long as they have the software has the update to decode Wi-Fi 6. So as long as you check with your application vendor, they should be able to tell you that.
Okay. This question is, would you recommend a AP on a stick or predictive survey?
Most of my surveys are predictive because AP on a stick for me takes a lot of time. And on a campus environment, it's very hard to do that unless you come in super early before anyone is there. And if you are doing it where there's people there, it just gets in the way. And I know a lot of faculty and staff do not like that. Yeah, I don't know if like that's the same with other campuses, but AP on a stick will get you more accuracy with where you're going to deploy Wi-Fi, especially when you're using the AP that you're going to deploy. Predictive gets me pretty close, but I always say do a validation afterwards for both your AP on a stick deployments and predictives.
Okay. And maybe just two more questions here. Do you ever change access point power levels, or do you let the controller select that more?
So I do both. Sometimes I see the controller doing a good job on RRM, and sometimes I don't, right? So for environments where I haven't redesigned it, I will do a static configuration, meaning I pick the channel and I pick the power, but more focused on the power. When it's a new design, sometimes I will let RRM pick just to see how well it does, or maybe there's some RRM parameters I need to change in order to get it to where I think it's at a good spot. But it's something I have to validate afterwards because I mean you could look at transmit power levels, but you do need to again do that validation survey to really see what that signal looks like. But I've seen problems where RRM either puts the transmit power too high or too low because the APs are very close to each other.
Okay. And one last question. Have you ever had people inquire about the health considerations of increased Wi-Fi penetration or increase in frequency such as 5G?
Um, that's a question about health concerns.
Yeah. Do you ever get
Um,
people concerned about the Wi-Fi
yeah,
signal penetration?
we do get a couple of those, and we either just remove the AP from their room. Um, I don't really know how to answer it because I'm not a scientist, but I always tell people there's so much frequency in the air, like your AM, FM radios, your microwaves, that I think Wi-Fi is gonna be the last thing that would harm us, because that operates at like 1/1000th of like power of a watt, right? Where your microwave, which operates also on 2.4 gigahertz, is operating at like 1,000 watts. So it's much, much more popular. And what I see when I do my validation surveys, so try this, guys, when you do your validation survey, or if you have a spectrum analyzer, um, put it on 2.4 gigahertz and then go microwave something and go watch your spectrum analyzer just shoot through the roof. That means you should replace the microwave because the shielding has deteriorated.
It's a good trick. um, so I think that's all we have time for. We have hit our time limit today. So Rowell, a lot of thank yous here on the comments and saying a great presentation. So thank you very much for being with us. And once again, to everyone still with us, be sure to check out Clear to Send. Rowell's got a lot of podcasts there with a lot of really valuable information on Wi-Fi that you should check out. And so that concludes our webinar for today. Thanks again, Rowell. Really appreciate having you on with us.
Yeah, thank you for having me, and thank you guys for listening.
Thanks, everyone. Bye-bye.